Hello, hello. Hello, hello. As you can see, we are doing something a little bit different today. I'm doing a lot of C programming recently, but you know what? I woke up this morning and I said, let's write some Rust. I don't know. That's not quite true. I've been working on this project for a couple of days now, just sort of scratching an itch, had an idea that that using Rust for an IP stack might be really convenient. Having those data structures in the standard library is probably very, very convenient for doing things like priority queue IP reassembly. So who knows whether we'll get quite there today. I have some small goals that I'd love to get to today, and if that is successful, maybe we can even do some slightly larger stuff. But I want to start simple, easy, no going too crazy. So why don't I just quickly demo what I already have. So it's a TCP IP stack. I've just basically barely started. As you can see, the only sort of protocol level files in here are ICMP, the control message protocol, and IP, the internet protocol, the basic like container of everything on the internet. So as you may be able to guess from that, all it can do is respond to ICMP packets, or pings, as most people will be more familiar. So I'll show that working really quickly. This is what happens when I run the program. Not much, right? You see, it's just sitting here blank. But if I open up another terminal, separate terminal, we've got this very interesting network adapter on this machine. So this is Ethernet. This is where my traffic to the internet is going, right? 192.168, whatever. But I've also got a different one here called Tun0. Tun is the Linux name for it means tunnel. These things are usually used for things like IPsec, like VPNs. Basically, it's a software network adapter. So if you were using this for a VPN, I could send traffic there, which would go to a program that could do something like encrypt it and send it somewhere else. But in this case, we're just using it to get network packets into this program. And it's got the adapter. My host machine has an IP there, 10.0.0.1. So if I send packets into that address range, say for example 10.0.0.2, it's going to leave my computer notionally. I mean, it's software, but it's going to notionally leave my computer from this 10.0.0.1, and it's going to go into my program. And very excitingly, it just comes back. So you can see it working. If I turn this off, I stop getting responses. It's definitely the program. And this is just printing out, hey, you know, I received this packet. 4.5 is the standard indicator, basically, that it's an IPv4 packet. Specifically, the 4 means IPv4, and the 5 is talking about the length of the header. But this is the first ping that we took in, and then this is the packet that I sent back out. So this arrow sort of in, this arrow sort of out. And this is what I sent back. So the header looks very similar, the data looks very similar, and if we were to just run this continuously, you can kind of spot there's a couple of bytes that change. Like this one changes. This is probably the timestamp. This is probably the checksum, maybe. There really isn't very much interesting going on in a ICMP ping. It's basically just some headers, and then all the major operating systems pick some random data that they want echoed back. So in this case, Mac OS is choosing, or Linux actually, because this is a Linux terminal. Linux is choosing 10, 11, 12, 13, 14, 15, 16, blah, 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 up through 37 as the data it wants echoed back. So that is what we're sending back. We're getting that in, and we send it back, because if you don't send back the same thing, It's not a working ping. So what I'd love to do is basically the exact same thing today, but for UDP. UDP is the, I don't know that it's the simplest. It's probably gosh darn close to the simplest useful data transfer protocol on the internet. It's very similar to this, right? Just headers and glob some data on the end, but it's got one extra header, which is a port number. Most people, I think, are familiar with those from like running Minecraft servers. UDP has a port number. That port number can be used to identify, right, where data is coming from. So it lets you actually reply, where a ping doesn't have a port number, so you couldn't ever have two applications using. You couldn't disambiguate who was asking for what. So it's not used for data transfer. I don't know. You wouldn't use it for data transfer anyway. But so, right, how would we do that? Well, we probably need a file. And represent that header as a structure so that we can query data about what that looks like, right? We're going to need to get things like the port number out of here eventually. We're probably not going to need to worry too much about it just yet. But I think the next thing we really need to know is, what does that structure look like? So I'm going to pull in a browser window here just so we can find what the UDP header looks like. No, I don't want geeks for geeks. Let's get Wikipedia. Wikipedia is usually really good at... there we go. So this is our header. Source port, destination port, length, checksum. Pretty easy. Trying to be consistent with whether I use len or length. All right. So now we're going to have to start getting into a bit of the weeds as far as how this library is going to work. So first thing I really desperately need to do, well, okay, I super definitely desperately need to tell Rust that this is not just a normal structure. It's not okay if you reorder these. It's not okay if you put in padding. I need these to be literally in this order, literally as is. And the next thing that I want to do is I want to add this little tag impl as slice for, in this case, it's going to be UDP header. And that is the main gist of how I have gotten this working. I will say this library is super, or this program, this stack, super early days. Just been working on it for a few days. It's not... I wouldn't... I haven't made all of the decisions about like APIs and stuff yet, but the way right now that I am serializing these packets is this trait as slice. So the trait as slice provides a function called as slice that turns a self into a slice of U8. And it's literally, right, very unsafe, very, not something that you're supposed to do in Rust necessarily. But it's assembling a slice from raw parts with the pointer being the pointer to itself, cast to a pointer to U8, and for its whole size. So the thing that lets me do is write it lets me write these functions. So I don't have to sort of manually glob together the packet from individual fields, which is something that I was really trying to avoid. This lets me take that header and just stick it into the packet very generically and ergonomically, and that ends up looking like that ends up just looking like this, right? Literally come up with so this is the ICMP response routine. Come up with that ICMP header and put it on the front of the packet. There's no other maneuvering. And then obviously there's still stuff that has to be done. You have to fill in the lengths. You have to fill in checksums and stuff. But I'm not entirely happy with where this is right now. I don't like those APIs very much, but early days, we're feeling it out. We're working on it. So I guess that's the next question is, what else do we need out of this? And I think if we're going to proof of concept this today, we probably want to be able to send a reply. And really the easiest way to do that is just going to be, I mean, what's a reply? It's swap the source and destination ports. If we're going to send the same data back, we can just use the same length, and then we'll have to recalculate the checksum later. But I think I just want to make something called like reply header that constructs basically the sort of mirrored version of this, right? So source port in the reply header is going to be self.destination port, and vice versa. Checksum. I'm going to make checksum 0 because checksum definitely will not work again. You don't get to just reuse it. And so this is at least a little clearer. If I turn around and send this packet without setting the checksum, it won't be a valid looking checksum. It'll just be 0. It should be a little easier to like tell that I've screwed up in that point. So let's make a helper then to actually do the checksum, which we have to figure out what the checksum is of. Is it a header checksum? Is it a data checksum? Also, what is the length? Does the length include the header? The length does include the header, so that's interesting. The checksum field is optional, but it doesn't tell me what it's checksum is the 16-bit ones complement of the ones complement sum, the pseudo header information. Okay. So UDP checksum is a little more complicated. It includes other information that we don't have here. So we're going to need to do something a little bit different. Here's the pseudo header. Source IP, destination IP, 0, protocol, UDP length, and then the UDP header along with all the data. So, it's sort of an interesting question is what will we want to do with that? So I see there's being sort of two options, right? We could make this struct and fill it in and then do the checksum over that. Or the checksum is just all network checksums, it seems. I'm sure some protocols do this differently, but all of the standard protocols use the same algorithm, which is just a sum of the 16-bit parts of the whole message. We might be able, because it's the IP, destination IP, the protocol is always the same. UDP length and length are probably always the same. It's not entirely clear to me. I might actually have to go look at the RC. Because if this is the UDP length, it's not the length from the IP header, and this is the length. I'm guessing those are the same. So we could just Well, so what do we definitely? We definitely know that we need self. We definitely know we need source IP. And this is, I guess we should be more clear. This is the IP checksum because the checksum would be different over IPv6. We need the destination IP. And protocol is always the same. Length is always the same. We already have the length. So I think that's probably enough. So how have I done this previously? Here's I have a helper routine that computes network checksums. It takes a U16 pointer, a length, and it takes the initial checksum in order to be able to sort of subtract that out of the final checksum. Just because the way these things are defined, if the checksum is already set, while you are computing the checksum, you treat the checksum as though it was 0, or else you'd have sort of a looping, you'd never actually converge to a value. So instead of actually setting it to 0, I just tell it to subtract that out, right? I say that initial value of the checksum is the inverse of the checksum. Do the calculation, and then if the checksum was 0, then you still have the right value. It just doesn't matter, right? That's the whole idea. But in this case, we need to do sort of like a additional. I'm sure we could do the math with just the one field, but I think the thing that I'm hoping we can make work is like copy this, have a like initial value, and just have the initial value be the one's complement sum of the current checksum and initial value. And so all that means is in UDP land, I have to name that checksum IV. That just means that in UDP land, I have to come up with that initial value by manipulating the source and destination IP. So by this point, the other thing that's really annoying about network protocols is that everything is big endian. So which that refers to the order that the bytes appear in memory. So for I guess these are really confusing. These diagrams are not helpful for explaining big endian because they do them right. This is backwards, that the bits are, it's displaying the bits in the reverse order. So, and that this is the low octet and this is the high octet. So it ends up being backwards. I can just let's just write a little tiny program. So we've got, let's have a number, 1003 U16. And let's print it out with all the zeros. Easy, right? 1003. Hex printed with all the zeros. The thing that endianness does is if I swap these bytes, so this is converting the number from big endian to little endian representation, essentially. You can see it's actually flipped the individual bytes. So instead of being the byte 10, then the byte 03, it's now the byte 03 and then the byte 10. So the within each octet, they're the same. But it has flipped the front byte and the back byte. And you can do the same thing for 32-bit, etc., right? You just flip them all around. And then the reason that this is relevant is you have to decide, because a memory location is a byte, is 1. So if I have a 32-bit number, I have to decide how do I store that in memory. So like, let's say this is memory. This is my memory, right? This is memory location hex 40,000. I need to store the bytes of my number. So do I store them for this number up here, right? 1003 hex. Do I store them like this? Or do I store them like this? And the choice you make, they're both valid. Just the choice you make depends on, well, constraints when you're designing your CPU. All major platforms today, all major CPUs use this version. Which looks more natural when you're reading it this way, but it looks less natural when you're reading it the typical way that memory is printed. No, I also have this wrong, right? Wait. Do I have this wrong? 10 is the high bits, is in the low memory address. I think that's right. I might need to check. Shall we do a little transmutation? So let's transmute our U16 into 2 bytes. If I can type transmute. And let's print that out nice and pretty. It would also help if I made these comments. Yes, that's unsafe. Correct. O310. Right, okay. So I've got this backwards. In case that was too fast. You see, if I print out hex 1003 as a pair of bytes, it comes out the low bytes in the low memory address. So the first address is the low part, and the higher address is the higher part, which sort of looks backwards to our eyes if we print things out the normal way, right to left, or left to right, with this being the low address and this being the high address. But the reason you do it this way is that you want the low bytes, as you're scanning up in memory, you want the low bytes to arrive at the CPU first because of carry addition. So if you had two numbers, right, you would add the low byte first. The carry of that goes into the input of adding the next byte. The carry out of that goes into the input of adding the next byte, etc. So this is why, it's essentially why all of the major platforms, right, x86, ARM, everything these days is using this ordering. But two things. One, it's not guaranteed. And two, the network does it the other way. The network puts the high byte first. So, long-winded spiral to say that you've got to be very careful when you deal with network bytes, because you don't necessarily know if they are the big half or the little half, big endian or little endian. So for this checksum, we can choose. Honestly, I think I'm kind of leaning towards just really making this pseudo header, just so that I can be confident, and maybe coming back as an optimization later, and doing this like Ivy stuff. But it's going to be very aggravating to get this correct. So let's just go ahead and do it right the first time. And then it was 0 protocol length. And then because of the way these checksums work, they don't actually check order. We can definitely just do them separately, right? We can do the UDP pseudo header, and then we can do the UDP header and the rest of the packet, and it doesn't actually make a difference because these they do not handle transpositions. They're sort of order independent. The protocol is always 17, which honestly we should probably just make a constant. We actually have that constant. Hold on. It's actually, and this even better, let's make this an IP proto object so that I can literally just say boom, just like that. And len is not a U8, len is a U16, and that is the same as self.len. So now we should be able to say length checksum. The thing that we're going to have to do then is do the rest of it. So this is like, I don't know, checksum 1. And then checksum 2 is the rest. This is all unsafe too. I have to fix that. So now we're checksumming self for self.len. So I think we're going to call this function unsafe actually instead of just because there is a safety consideration on calling it. You have to ensure that the UDP length has been set and is correct. One. Something like that. And then the answer is ooh, that may not be correct. All right. We just like super definitely have to write a test is the answer. Does the Wikipedia article have a very convenient test for us? If not, we can just invent one very, very easily. It does not appear to, but we can invent one very, very easily. Okay, so how are we going to do that? Well, we have a working implementation of UDP on this computer that is perfectly capable of producing valid header checksums. Let's use it. I don't even have tmux. Plan is to create a UDP request packet using probably netcat or something and dump it out using something like TCP dump and just use the header that we get out of that. So, I mean, that should be very easy to do. I guess it doesn't actually come through if you're not running a program. Okay. So this is a packet. We just need to get TCP dump verbose enough that we get the actual like data and everything. Well, it's not that. So we're just gonna have to start reading the manual page. Oops. Parsing and printing, print the headers of each packet, print the data and its link level in hex. So -XX. There we go. That is a valid packet. And I think we're gonna use small x and see if that gets slightly better. Formatting is pretty much the same. We can see exactly what we were expecting, right? 45, we talked about the 45 earlier. It's IPv4. Our addresses are right here, 10001, A001. You can see the big endian order that I talked about, 10001. It's not backwards. Here's the destination, 10002. I did not pick an identifiable port number. I picked 1000. I think 3E8 is 1000. So this is probably the ephemeral source port. This is probably the destination port. Not entirely sure. There's an 11 here. That might be... There's a couple of 11s. One of those 11s is the ether type. Actually, this is probably the length. This is probably the UDP checksum, right? And then this is the data, obviously. I'm not sure where it exactly starts, and I'm not sure what this I is doing here, but that's totally cool. Exactly what we were looking for. So we just need to convert this into a Rust data structure, and then we've got exactly what we needed for a test. So I did something very similar. I think I actually just took the example from Wikipedia, but I did the very same thing for the IP checksum test. And that's what we're going to do here. So UDP, we're going to let our, I don't know, call it buffer. I don't know what I call these things. And then we're going to have to clean that up, obviously. So what does this look like? It's for every 2 characters, OX, that, comma, space. Perfect. Get rid of some spaces on the end, and then I don't need to reflow this because cargo will do that for me. I would have reflowed it, but look at that, beautiful. So we don't actually care about it being mutable, so because we're just going to get the computed checksum, and then we're going to find what it is in there and expect that it's correct. So that's star const UDP header. Not yet, because it's then that. And then And then we're just gonna, well, I guess we're gonna wanna, we need to assert something, because if the test doesn't fail, it won't print anything. Not without me figuring out how that works. We're gonna print out the value of this is actually IP checksum, because there's more than one. We have to give it source IP and destination IP, which are going to have to be big endian. Source IP, OA, 00001, destination. This is also wrong, incidentally. This is wrong because it's an entire IP packet. We have to figure out where the UDP header starts. Whoops. Well, okay, but no, we don't. No, we don't, because we know that IP header length, it's right here. This character, being a 5, tells me that the IP header length is 20 bytes. So that should be fine. Let's see if it works. Need to import things. No IP proto, it's IP protocol. Protocol. And the other one was create as slice. You don't like that. Let's just start attacking these. Expected U16 found struct UDP IP pseudo header. Expected U16. Oh, because it's a, yeah. What did I, oh, expect, okay, yeah, it expects a pointer to U16. That's both of them, probably. What did I do in ICMP land? That seems really annoying. Exactly that. That'll fix itself. UDP IP pseudo as there is no, yes. I copy paste errored that. IP checksum implicitly returns oh my. Didn't I fix this? We'll investigate that later. Yes. Good enough. Okay. That didn't... Oh, because we segfaulted in a different place. I'm not entirely sure why this is broken, but I'm not entirely sure what this is doing. We've got a 32 byte buffer. We're assigning OX45 into it, so we're making it kind of vaguely look like an IP packet. We're making a packet out of that. Why would that segfault? Oh, maybe. I'd love to know why that's happening. Test B swap. Huh? Okay, there we go. I don't know what the heck is going on with this thing. It's like that's failing. Very strange. Okay, it's still doing weird things. We're gonna have to figure out what the heck's going on with that. But this is our theoretically correct. Why is that printing? So 56060. A, why are they different? That doesn't make any sense to me. I wanted that to be in hex. That was the whole point. It's not. Where are we segfaulting in a test? I'm doing really terrible things here, obviously. I mean, it very well could be that this is the thing. Yeah, I mean, it's, well, so that's a fail. That's a normal fail, normal fail. These are all just normal fails. So why is it when we were doing the other thing we were getting seg faults? I don't understand. That doesn't make any sense to me. Okay. We definitely expect it to fail. We know it's going to fail. Did I just see? Okay. Well, that's probably related to why it's doing bad things, because this is changing. And it's definitely not supposed to do that. So let's start with a little debug print of what's going on in there. Header. What does that header look like? Well, that's just wrong. But that's, I mean, len is not that. That's not correct. So obviously we have the offset wrong or something. Yep. Okay. So yeah. This is where we need it. So if we convert it to a UDP header and then we offset 20, we're going 20 UDP headers off, which is, 80 bytes. No, it's 8 bytes, so even more. 160 bytes, which would definitely cause segfaults. We want to offset here. So that we're offsetting in bytes. That should at least be, no, it's still not consistent. So we've still done things wonky, screwy. We've done bad. We printed out the header. Does the header look somewhat reasonable? No, it does not look reasonable. Is it at least consistent? The header is at least consistent, but it's definitely wrong because the source port is not 84. The destination port is not 0. Who knows what that length is, but it's wrong. So where does the UDP packet begin? Let's see if we can figure this out without thinking too hard, but we probably won't be able to. Version IHL, DSP, ACN, total length, I think. Flags, frag. No, this is flags, frag. Source IP, destination IP. And then that should be the end, right? It should be right here. So how many is this? $21? No, 20. Which makes sense, right? It's claiming to have an offset of 20. I guess we're going to have to do this in parts. What am I doing? This is ridiculous. Why am I, no. Buffer 20 ... as putter. Let's not ask any questions about the offset. Let's just, still the same behavior. But I mean, we can like print that. O2X question mark. Yeah, I expect bananas numbers, but those are not the numbers because they're still big endian. But I think I thought I handled that. I hope I handled that. I tried to handle that. 84BA, 3E, 03E8, 0014, 1149, 48. This is, I mean, that's what I expected to see. Source port, destination port, length, checksum, data. This is exactly what I expected to see. So why is that a U8? Did I say it was supposed to be a U8? No, I definitely said it was a U16. So we can note some interesting facts here. For example, source port is the same as this. Len is the same as this. Destination port is nothing. Checksum is obviously nothing. Don't know that those are necessarily related, but it's certainly suspicious. Additionally suspicious, this is not changing. Well, okay, but the length is ridiculous, so that's why this is going crazy. So why would that just not be right? Repr packed. Oh, nope, I've got it. I got it. I figured it out. I know what's going on. Yep. Yep. I know exactly what's going on. Why would this be this and then this be 0? This is printing correctly, right? But what is the type of this array? I never told Rust to make them bytes, so it inferred I32 is the default. This is the bottom 16 bits of 8.4. This is the top 16 bits of 8.4. This is the bottom 16 bits of BA, and this is the top 16 bits of BA. I told it to give me a buffer of whatever. What I needed was to tell it buffer of U8, and now it will work. Oh, I didn't even get, it wasn't even a buffer, it was just a flat array. Boom. Now we at least get consistent behavior. It's not, it is a number. It is not any number that appears in here, which tells me that we are still doing something wrong. 3822, when I believe the correct, what did we say? Source port, destination port, length, checksum. The correct answer is 4911. Which is super suspiciously close to this. That's this +1 +1 -1 -1. I don't know, that might be a coincidence, but that's something. That's something. Like, this might be wrong. Just gonna start 2238. That's just flipped it. Expecting 1149. I guess we can 4911. We can put that in here. 4911. So it's sort of suspiciously close. I mean, I don't know that I believe this. It's not like that, is it? No. C7DD. If it's the... Unfortunately, network checksum is doing more. I need like a network partial checksum is what I need. Either way, right? Whatever we end up with, we're going to want to have a partial checksum, I think. And that's not going to take a checksum. It's not going to do any swapping of bytes. It's literally just going to do this and return ACK. And then this can do the full thing can do that, but no, that's not gonna work. Well, okay. We can leave... whoops. We can leave this alone, because we know this works. What I want is just the... Give me the ones complement sum of a pointer and length. That's all I care about. Because... This is now the ones complement sum of all of it, not dealing with the checksum, right? So this is the, like, and now now this is, we need to subtract out the effect of the checksum. That seems kind of weird, but we're gonna leave it there for now because this is what we did in the other one. And then it should be not be what did we do there? Yeah, I was gonna say I thought the not was in the parens, but it didn't. All right, does that yes, use, we're not using checksum at all anymore. And that's the exact same number that we had before. I mean, tells you I'm consistent. Whatever mistake I'm making, I'm doing it in the exact same way, despite completely rewriting the entire thing. What if it wasn't that? Delimiters. 005A. That's very different. Still very close. Again, one off, one off, one off, one off. It's the opposite direction for all of them, but they're only one off now. So is the partial checksum like 2200 or something? Oh gosh. So what's the other option? What is this logic? The thing that I'm thinking is that maybe, because I think pseudo headers are pretty common. Well, so I mean we could, like, we can go back to doing the math, right? That I suspect that the answer is with the source IP is already byte swapped, and destination IP. They're already big endian. And then what else fields are there? We know that the length is there. Again, can totally be not byte swapped because none of these is byte swapped. It's all big endian. And then the last thing in the pseudo header is the protocol. So what did we call that? We called that LC. It would be really nice and do it right by referring to the constant. And then the belief is that we can call network checksum of and with the third argument, the previous checksum which gets verted out, we definitely need self.checksum to be in there. But the suspicion is maybe we can do like plus not PC or something, right? Because this is going to get inverted. I guess this probably has to be one's complement. So let's see if that gets us anywhere. There's no such thing as len. It's called len. Byte swap not found in U. It's swap bytes. IP protocol UDP 0 as. Ooh, actually. I suspect we actually want to shift that up, because this field, no, we don't want to shift it up because this field has zeros here. So definitely as U16, definitely not shifted. And then I can't do that, so we're gonna just cheat and say screw it, this is the number 17 and it will always be the number 17. And I pulled that out of my includes. We're not using this anymore. And that worked, apparently. Okay, how's that for a whirlwind? I made so many unwarranted assumptions in this function. What the hell? How did that work? Really? I want another example. I don't like that. That's too weird. Program needs to be running. Oh. I also definitely haven't handled the case where it ends shy of that. Well, this one's not going to work for various reasons. Didn't I copy this? Get rid of all the spaces. Make it pretty. Format. So this is just exactly the same as this. The IPs are definitely the same. We do have to come up with what the header is, or what the checksum is. The actual checksum in this packet is source IP, destination IP, source port, destination port, length 3E86. And we have another problem. And that problem is header with 0 octets at the end to make a multiple of 2. So we have to convince our thing to read it like that. And it's super not set up to do that because I'm just reading it as pointer to U16. I guess, okay. There is a solution here though, because I have the full length. If the length is odd, then we need to unfortunately, pointer is a pointer to const U16, so I cannot safely read the that, but I can safely read so this is the value of the last byte that that as U16 shifted over by 8 because it's big endian. And that should just work, hopefully. Length is a U size, offset is an I size. Booleans. I have to put more parentheses because Rust requires it. More parentheses because it requireth it. Wow. And that also just worked first time. I need to like leave myself a comment. For some reason, every time I write comments, I end up with one word on the end. Oh, that was fine. Hold on. What is it? G. I mean, that's the right command, but it's refloated a little crazy. What do you think? You think the text width is 99. I say no, the text width is 80. That's better. Actually, I'd rather the text width be like 72 though. That's better. Okay. Yeah, I don't like it, but you know, this is the world that we live in. I think we are going to do one of these as well. Not source IP. I did this exact sort of thing for the IP header. And it's quite convenient. So I'm gonna keep doing it. I don't remember whether I bothered swapping the checksum bytes. They're sort of useless anyway. So let's just be consistent and see what we did. Let's put this back as well. Since we found the problem with the tests. We did swap the checksum bytes. All right, cool. So we've got reply header, we've got bswap. We can set checksums, though we don't actually have to. It's still optional, but whatever. I think we might be able to try incorporating this into the pipeline. See if we can't reply to some packets. Where is the pipeline? Handle IP. If the protocol is IP protocol UDP, we'd like to call handle UDP, which we'll probably put right below echo maybe. At this point, we have already called, when do we call IP? We do the IPB swap like way up here. I think we're just going to do this one down here. So so we're going to get the UDP header, which we don't have this interface yet. It goes, we need 2 of them. Yep, that's exactly what I want. It's an L4 protocol. We're going to have to import this here. That is private. We should fix that. This needs to be public. This needs to be public. Okay. So now we can place a checksum. We want to be able to what's wrong? Nothing is wrong. Yeah. So we want to swap that. We do not have a, yeah. So the next question, I guess, is do we make like a send UDP? Really what we will want in the future is a send UDP that takes some sort of session or socket or connection object. We don't have one of those right now, because I haven't defined what that's going to look like. I think I probably want to just do the exact same thing that I have here for ICMP. Just duplicate this for UDP, just so that we can demonstrate that like the checksums actually work, really send a packet. And so the interface here is the packet that we're passing in is the, like we reply to this packet. So we have some helpers, right, which we've just built, the UDP ones. So these are now the machine endian, the my endian reply headers, right? That's the reply IP header and the reply UDP header. This is what we're going to need to send. We've got the same problem here as we have above. We need to know the length of the data. Okay. The IP total length. IP total length is the total length of the packet, exactly as we had before. The UDP total length we also have to set. And that is data len plus 8. Data len as U16 plus 8. Because the UDP length is the length of the data plus the length of the UDP header, which is always 8. This is definitely not how I would want that to be long term, but that's how we're going to encode it right now. We need to swap the UDP header. We need to swap them both. This is unwrap. Get them into network endian, and then we need the source IP and the destination IP in network endian. And that is so we can call set checksum. Okay. And then we need to set the IP checksum. That's unsafe. And then we should be able to send it. Hopefully. All right, shall we see what I've forgotten? Yes, this is a horrible mess. I really, really dislike this interface. I really dislike having to call this every time. The problem is because I can't tell Rust. These are just functions that take a mutable self parameter. I can't tell it IP header and UDP header are disjoint borrows. Like they could both exist at the same time mutably and everything would be fine, right? It is impossible, I declare, for the result of IP header mute and the result of UDP header mute to alias. They will always be different things. But I don't know how to tell the compiler that without doing some... I mean, it's just a method that takes a self parameter, right? Like disjoint borrows on structs barely exist, and on arrays that are inside of other things based on, like, it certainly couldn't prove that with all the nonsense that's going on inside these methods. So hopefully that'll get better. I will find a better way eventually, I'm sure. Does it build? It does not build. It does not build because I need to be able to access UDP internals. Very reasonable. Totally reasonable. Did I really not name? I really did not name them source IP and destination IP. I really named them source and destination. I don't know that I like that. We're gonna keep it for now. Oh gosh. Oh gosh. We're gonna keep it for now because I'm not gonna change it right now, but that's, I think, really questionable. Set IP checksum is private. That's definitely wrong. We need to fix that. Hub bswap UDP header is a questionable help text Rust. I don't have a type there, but yes, I know what you mean and I will fix it. This needed to be a UDP header mutable. And now it will, well, it builds. It didn't do anything. It did nothing. Why did it do nothing? Oh, because I never call... I never actually called the function that I wrote. So we're going to reply to packet with, heck, why don't we do something different, right? With the ICMP, you always have to respond with the right data. But here we could reply with, like, this is your reply. We don't have to reply with the same data. Okay. Data was sent back to the right port. Didn't appear though. Gonna guess, I mean, the implication there is usually something like a bad checksum. So let's put this in verbose mode so that we can find out. Survey says it's not complaining. IP proto 17 length 32 from 10.001 46.499 to 10.002 25.500. Seems to imply that that was correct. I mean, I guess I should verify that Netcat even allows this. If we sent it to ourselves. That didn't work at all because this is listening on TCP. Yeah, so replies are definitely supposed to come through to the same thing, place, the same whatever it's called. And the ports are right. 10.001, 41231, 10.002, 2550, 10.002, 2550, back to 10.001, 41, 231. It's not like I'm messing that up. The ID is the same. Maybe that's not supposed to be the case. I mean, we could just do this again so that we can see. So let's do like 25,500 in the background and see 25,500 UDP. That won't come through on here. Is it just called LO? It is called LO. So let's do this again on that's fine. Localhost. It did reply, but we only saw one packet. Why did we only see one packet? We only see the to packet. We don't see the return. Wait, but now we're not getting a return. What? Echo actually gets a return, but it doesn't print it. That's really not helpful. Okay. I wonder if Wireshark would print the right... Well, no, because I'm not on the right machine. This is through SSH, so I can't just Wireshark it. We could do it. Oh, I know why I'm not getting a response, because I'm not typing at the... It's not an echo server. It's not supposed to respond. It's doing exactly what it's supposed to do. So I just need more screens. That's the answer. $25,500 and see localhost, well, UDP, localhost, hi, that's fine, back at, yeah. Okay, so it is a different IP ID. That's potentially interesting. Seems like it shouldn't really be necessary, but we can try it. Just change that and see if it makes a difference. I mean, it's very easy to do. Not that I know how. How do you use rand? Seems very weird that it would be. That it would require a different IP ID. I mean, yes, like, sure, doing it that way is probably wrong, but rand thread RNG. What else did we set? We set the total len, so we'll do it right here. The IP header mute dot ID, the IP ID is RNG dot get. It's definitely not in here. Rand is version 084. And that's going to take a hot second to think about that. There we go. What do you mean it's not found? That's what you told me to do. Oh, gen, not get. No. Oh, yeah. Gen. Okay. Mutable. It's like in my back buffer, so I keep opening the cover of the tunnel. All right. That's something. And so we're sending it to 10.002. Anything, it doesn't matter. Still nothing. Let's take this back to the right interface. Random ID. Decremented TTL, you know, we've done everything. Sure looks right. I mean, there's a little bit of sort of difference in this structure. Like, what is this? So that's a source IP, that's a destination IP, which means that is UDP source port, UDP destination port, UDP data length, UDP checksum. So, okay. So the blank n and the tilde blank are the checksum. So that is just hi. Well, oh yeah, because I wrote two i's. That's why there's two i's. What a concept. But I really don't understand why that's not. I mean, it looks exactly like this one, right? Just right back at the same place. I wonder if strace would give us anything. strace, the syscall finder. It reads hi from It writes hi, and now it's just polling for events on the file descriptor. And the kernel is not giving it one. This definitely worked for ICMP, so I'd be a little surprised if the writing function is just wrong. Write packet.whole is from the beginning of the L3 header to the end of the entire buffer, and we see it correctly in TCP dump, so we know it's writing the right thing. And we can see it in the if there's some cache thing. It should work for 3 as well, but it doesn't. Oh, because I'm not running the program. Helps if you run the program. No, I mean, it doesn't change. Wait. No, yeah, it doesn't change the behavior. TTL63. ID random. Offset 0. Flags DF. Proto UDP length 49. How can I get more verbosity? How can I get something? No, I don't want to dump it in C program format. Timestamps, microseconds, nanoseconds, secrets, don't convert addresses, print packet numbers, don't use the optimizer, timestamps and deltas and stuff. Okay, so 3Vs is even more verbose, they say. But we don't actually get any more information out of it. Oh, no, it's right there. Has it been saying that this whole time? It has not been saying that this whole time. I needed more V's to see that the UDP checksum is bad. Okay. Thought I was going crazy. Let's sanity check something quickly, which is we do know that UDP checksums are optional in IPv4, so we should be able, maybe, we'll see. We would like to see if it is possible to, instead of, or maybe after, maybe not instead of, maybe after calling set IP checksum, just say .checksum equals 0. Just to see if that makes a difference in the behavior. And it does make a difference in the behavior. So that's definitely the problem. So that works, clearly. So how's that for fun? That I can write multiple tests that the UDP checksum is okay, and then I go to use it and it's still broken. And now, ooh, wait, actually, I bet I have, so are those IPs correct? Yeah, I used reply headers, source, and destination. So that should be right. They are big endian, right? They're post BSWAP, but that's correct. We wanted that. Right, this was filled before, this was filled before, but it doesn't matter. This was filled before, then we swapped. That's what we were going for. Whether correct or not, it's certainly what I wanted to do. Let's take a closer look at this wrongness. Let's see if this is 9161 to A250. So that is off by 1 in every position, right? 9A 1 2 6 5 1 0. It's off by 1 in every position, which incidentally is the problem that we were having before. Yeah, 9161 is what we have here. So let's go ahead and just make this another test. Let's see if it even behaves correctly in the test universe. So this is our packet. No. Control V, not Command V. Let's get rid of this ASCII art. Okay, the header is that, the checksum is that. We know the checksum is supposed to be A250, but that's big endian. The correct answer is OX50A2. A2 in post endianness. I don't know why I'm there. Oh yeah, and then the other thing that we wanted to check was that this is, okay, so this is source IP 10003, destination IP 10001. So source IP 10003, destination IP 10001. Okay. And that fails correctly, naturally, gladly. We expect 5082. What we get is, because if it didn't fail, I don't know what the heck I would do. Just honestly, just copy that and replace. We actually got, yes. 4x 51A1, which is also not what this says. This says we got 9161. And in fact, we did get 9161. Right, that's just the truth. We actually placed 9161. So why would this be different and wrong? Did I wonder if I did just the straight up. No, because this is, it takes self, right? And the self is definitely in the right place in the packet. I was thinking for a second there that I might have like accidentally read too much, right? Like started it at the beginning of the IP header or something like that, but that's not. That's not really the case. So why does it work for these two and not for that one? Right, I mean, this example was, well, yeah, this example was taken straight from Wikipedia. That's not true. I made this example up. Maybe that's the problem. Should we find an example UDP packet? I know how to do it. I want an example packet. Well, that's not helpful. Oh, come on. Just give me a, like, really convenient sawed off. Nobody has examples. Okay. I mean, we got all of these from TCP dump, but they shouldn't behave differently, at least. Theoretically. Right, so that is potentially interesting that I haven't been trying to calculate checksums with the incorrect checksum there. We hoped that this was correct, but it may be wrong for calculating things with the wrong thing already in place. That's totally possible. And to be like off by ones and stuff seems really reasonable. I mean, really? Terminal's gone all weird and decided that Control V should be not visual selection mode. If I was going to do this correctly, if we were going to just rethink this a little tiny bit, I think the next thing that I would probably do is like know that multi-part checksums are really common. These pseudo header checksums are really common. So I would make like a 2-part function that takes 2 pointers and 2 lengths. What the heck just happened? Okay. So we would make a 2-part that takes 2 pointers and 2 lengths. And it does all of this for the first one. And then it just does it again for the second one. 2, length 2, pointer 2, length 2. Does this make me sad? Yes. Does this make me want to cry? Yes. Is it necessary? For now. So what is this? This is a network checksum 2-part of self as pseudo header UDP IP pseudo header as size of self.checksum dot swap bytes. I think. Wait, no. We do that in here. Yeah. Self.checksum. Maybe? It would help if it was conser. Conservation is great. Conser is not. Alright. Things don't work. Self dot, there's no self dot length. There's only a self dot len. Is that right? If the len is correct, yeah, that's right. Pseudo headers, yes. And you don't like the fact that I haven't imported the function. Okay. Boom. No checksum. Almost. It'd be helpful if we ran test first. Nope, they all failed. Okay. Helpful. Okay, so that's wrong. Why? I mean, maybe all of my examples are wrong. Honestly, I think probably the better thing to do would be to just try it first. Because I would definitely believe that all of the examples are more wrong than reality. So let's just not set this to 0. Earn UDP sum okay. All of the examples are wrong. Woo! Every single one of them. But this is like the trivial case. You just do the first pass and then you do the second pass and then you're done. So we did it correctly. Ladies and gentlemen, that only took like, what, an hour to do the freaking UDP checksums. Very cool. Please do let me know if you have any questions about what we've done. I'm more than happy to go back and talk about stuff or slow down or speed up or whatever you want. But I think it's time to commit this. This is not the working directory. We added random because we needed random, which in turn added 50,000 things. We added all the UDP handling to that. We added network checksum 2-part. Apparently we changed ton alloc. Oh, because I made it unsafe. Or I made it safe. That's fine. It would be nice if we didn't comment out that test in this commit. This is why you check, even if you're sure. Oh yeah, and all the tests are failing. That's not helping. Literally all of them, including the sub one. How is this failing? How is this failing? This is like such a trivial test. Just make an IP header and checksum it, and it's all zeros except for OX45. So the checksum is OX45, not that. That's just so... Right? Like, what does it print? FFBA. Okay, so I guess that's... Yeah, actually, that might be right. If it is the ones complement sum. Okay. Oh, I think I see. So I bet you that's just B swapped. Yeah, FFBA, yep. It's because I'm thinking in Little Endian and it's not. That's one passing. All right. Now let's do the UDP ones and see what is wrong with my brain, because it's clearly something. Let's just always print what we expect it, what I hope it to be. So this one is 3E86, and this is 1.2, and this one's 4911, and the IPs are the same. They're just super different. 3822. No, they're not super different. They're mostly one off. 4 3 9 8 1 1 2 1 2 1 2 1 2 3 2 ED 8 9 6 7. They're one off. And then the 0, I presume, means that the 2 doesn't have to be different because there's a 0 in the first position. So why did I believe, like, the 5082, why did I believe that was right? I believed that was right because we saw it over here, right? It said it should have been A250. Why? Why not 40B2? I don't know. What do I believe more? The fact that it's working now, or TCP dump? Like, okay. Like, this is an outbound packet, right? This packet was hashed by Linux. So let's not make any assumptions. We're going to solve the problem of too many failing tests by adding a test. The hope being that this one will just be perfect, because that's always how this works. It's always how that works. Everything works out in the end. Udp header and that. And then the other question is, where is and what is the checksum? And the answer is, this is the source IP, of which 1, 3. This is the source IP. This is the destination IP. This is the UDP source port, destination port. Do I believe that? Maybe it's destination port, source port. I believe that. 1, 3. $5,000. Maybe I don't believe that. I certainly don't remember using port 5000. I remember using port 25,000. 9C63. 8813. 63 9C. That's the port I use. Okay, so I bet this is actually just a coincidence. I bet this is the source port, 8813, and the destination port is 63 9C. Is that consistent? 8813, 63 9C. Yeah. Source port, destination port. Whew. Length, checksum. Checksum. Big endian. So 8dBB, or it might be BB8D. I don't know. Obviously, this we had to interpret big. So I guess the answer is we should interpret this bing instead of trying to flip it. It should be 8dBB. That's the guess. The assumption, the hope, is that this is 8dBB, which is not the same as the assumption I was making before, but that's because I wasn't thinking very clearly. We said the source IP is 1, the destination IP is 3. We do believe that's the right order. It is the right order. Source IP is 1, destination IP is 3. Let's fix that here. Not get that wrong. That would be bad. Actually, I don't think it would matter, because the UDP checksum is not resilient to a byte transposition. It would be all the same bytes in different places. So yeah, it literally doesn't care if you flip the source and destination. That's kind of terrible. Who designed this? Somebody who wanted to make me have a bad day, that's for sure. 4. I should really just factor this, but whatever. No, it's still coming up with 1 off. Yeah, I don't believe this. I really don't. But do I believe this? I bet this is going to work, though. So we're going to make it a mutable pointer. We're going to set the checksum to 0. Right? Because it's, as it is, in the binary, it's 8813. Or not 88, whatever we said it was. 8D. Where the hell is it? 8DDB. Gosh. HI enter. 8DDB. So if we set it to 0, cast star mute UA to star mute. What? Why is that invalid? I mean, sure, but I don't want to unmute U8. I want an unmute single U8. U8. What? Slice.asMute does not. Standard slice. I want the primitive type as. Oh, lovely. That for slice it's as mutable pointer, but for pointer it's as mute, and for option it's as mute to get an option unmute t. Oh my goodness. So it is as mute header, and that doesn't like the fact that this is immutable, and then this is immutable, and then this doesn't have to be mutable. Oh god. Udp header is an ampersand reference. How do I make it not be, oh my goodness, this one. Just gotta really put that everywhere. And it's okay, so that did not change the behavior. I was expecting that the problem would be in my implementation of, why does this work? Right? How, like, if the checksum is wrong, why does it work? That's what I don't get. If I do the same sum on this packet, well, this packet come the rest of it, right, minus the IP header, I get something different. And it's not off by OA, right? I don't think it's going to be this byte here. Why does it work if it says it does, if every test fails? It's like such a great candidate for testing. I really don't want to commit it with the tests broken. What if we well, there's a case that we haven't tried yet. This is a packet that was hashed, that was checksummed by Linux. This is a packet that was checksummed by me, but it was checksummed wrong. Let's grab one of these that is checksummed and that TCP dump and the Linux kernel believe are correct, and try that. This is getting real old. We're gonna do the mutable version because it might be helpful. Well, I'm not like breaking the packet in this. 45, right? So top row 45 to 03, OA 73, 20 OD, 40 03, OA 73, 20 OD, OA. Yep, no, like that's the same data. It's not like I'm doing something wrong there. Same. No. That one's even worse. Look at this. No, sorry, I didn't fill in the right checksum. I was gonna say. Yeah. So, what is the checksum? And what are the IPs involved? The IPs are 3 to 1. Three, one, source port, destination, one of the ports, the other port, length, 9DF4. Which is actually sort of even worse. Oh, we didn't print the right thing. Now they're byte swapped and off by the 1, right? EF 9A DD44, but it's byte swapped too. And that's what's literally in the packet. What happens if we instead of calling the checksum function, why don't we set it? I do the whole operation. Same everything. Same everything. No change there. I mean, that's good. At least it's not changing from that. From whether the initial value is set or not. Like, at least we're subtracting the checksum out correctly, or at least it seems like we are. Not using the wrong positioning. I mean, why are we getting... I guess that's the next, like, really interesting question is, why are we getting different values? Now, so I can't make this reproducible, right? Because this has a randomized IP ID, but we can make it reproducible if I change that and don't randomize the IP IDs anymore, which now I think is actually going to be okay. I thought it was a problem before, but now I don't. IP ID is, because we did this rng.gen stuff back before we found the fact that the checksum was wrong, well, forever ago. So let's make the ID like 1 every single time. So now, if I run this, every single packet that I send should have the exact same everything. And they do. They're all exactly the same. And where's the last one that was randomized so that I can see the difference? Now I've sent too many. ID one. It was because I was scanning for this same like ID1 right above UDP sum okay, but it was line wrapping before. There we go. So this is the last one. We said this was the checksum field, didn't we? Oh. It doesn't make a difference. The IP ID doesn't change the DOI. The UDP checksum doesn't hit the IP header. So yes, of course, I'm sitting here going, what? They're all the same? Yeah, they're all the same because it hasn't changed. It's the same ports, it's the same IPs, and it's the same so here we see, I mean, like I'm deep in enough that I want to just source port, destination port, length, checksum. Source port, destination port, length, checksum. 90F4 is what we see on the wire. 90F4 is what we see on the wire, but when I test it in cargo test, I get E4AD. Am I printing the right thing? When I test it in cargo test, I get different thing. Why? Let's make a real packet. So that we can get the header the same way we would in a real packet. What is it? New? Is it new? What did I do? I changed this the other day so that it would. Yeah, new. Well, new takes a evacuate. Oh well, we'll just make one. So that's the packet. Packet.L3 offset is the IP header. The IP header is at 0 in this. The L4 offset is the UDP header. The UDP header is 20 bytes in. So UDP header now should be packet.UDP header. Should do exactly the same thing. Packet should do exactly the same thing we were doing before. We don't have packet. UDP header is an ampersand reference. UDP header mutable. And it's still failing, and it's still failing in the exact same way for the exact same reason. So, but the thing that's nice about this it would be as convenient as well if we printed this out and just saw that it was actually the correct. We shouldn't have made that hex because now I can't read it. Source port, random. Destination port, random. That's all. Okay, yeah. I guess I probably should have made these. Well, no. What I should do is I should swap it to little endian just long enough to print it. Source port 25500. Is that right? Yes, that's right. Destination port, ephemeral, len 29, checksum. I mean, the value doesn't matter. Reasonable. It's that confirms that we're like not at the wrong offset, right? We're at least actually looking at a UDP header and the right UDP header. So what is different between this invocation and this one? Because this one sets the checksum to 9F 94, whatever, the one with a 9 in it. And the other one does not. It does a different thing. And at least it's completely reproducible now, so we can like really, you know, dive. Let's print source and destination. Maybe we have those off, wrong. They should be, I don't know what they should be. 08X. And actually, we can just grab this whole thing for this. We can put it right there. And we can make this really use source and destination IP too. Reply packet is wrong. This should just be packet. Also, that's not going to work because of scoping. Because I can't prove to the compiler that this is a disjoint borrow. So now I have to ruin my function. By making every single borrow single line. And these are all optional. And that's actually fine. That's all of them. Well, it's not all of them, but then after this we can say this has got to be mutable. Source IP, destination IP. We need mutable that to be exist. That's fine. That exists. And now it passes the test. So what the hell did we change? Because I was under the impression that all of those things were the same. How do I get it to print output? not quiet. I want the opposite of quiet. I want you to print everything. Well, okay. There's a solution to this problem. It doesn't help if you put -- help there. Okay. So that's the problem. Yeah. Some of these I probably have the wrong. But the problem is that I've been writing the IP like this, and I thought this was fine because I expected it to be in big endian format. But I was wrong about that. I need to be writing it like this, backwards. Oh God, is this the right number? Yes. So it was me being dumb the whole time. Let's just check that actually makes number 4 pass. It does not. Okay, stop. Let's not panic that. That does not make number 4 pass because it's B-swapped. But we expect that, right? I'm not surprised that there are some of these that are B-swapped. Now 4 passes. All right, so we want to replace everywhere. OA, OO, OO, OOO. Anything with that OO, OO, OA everywhere. And they all pass. All right. Cool. Endianness. I do not need all of these tests. I super certainly don't need test 5. And really, I think I just kind of want... I think I like these later ones a little bit better. So we'll do like maybe that's 2 and that's 1. And these 2 go away. Because I don't need 18 different tests. Okay. Now we can commit this. Whew. It's kind of what that is. It's not really an echo server, but it's basically the mode it's in. Whew, indeed. All right, so what next? I mean, we could try for sessions. I mean, I don't think that's really very necessary for UDP, at least not now. Not until I have a better sense of what I want to do. Could start on TCP. That would be very entertaining, to be sure, if I can't write a checksum. But a lot of that work should be pretty transferable to TCP. I mean, we could certainly at least start by writing a header. So what's the TCP header look like? I guess I could put this over here, at least this long. Oh, I can make this smaller. So you can follow along with the thrilling TCP header. TCP header, interesting because it has flags and stuff, so it's going to involve a little bit more finagling as far as being able to properly view what's going on. Can one of these be not terrible, please? That's fine, I guess. Acceptable. Refer packet, that would be entertaining, if only. Packed struct so that it doesn't get oofed. Source port, U16, destination port, U16, sequence. Do I want to be really explicit? I do. I do like being really explicit. Acknowledgement is too big, though. That's too explicit. So we might name that seek, I don't know. Okay, so this is, it's almost all flags, but it's not all flags. That's 16 bits of header length and flags. Oh. I'm presuming that checksum is going to be the exact same situation that we just dealt with. Honestly, we should probably just go straight to TCP sudo header. I bet you anything it looks exactly like the UDP one we just did. Yup. Yep, it's literally exactly the same. So that's a TCP IP pseudo header, because it will be different in IPv6, and that's, I mean, this is where networking starts to get really annoying, right? Is these like cross-layer dependencies that the checksum at layer 4 in TCP land is actually different and calculated completely differently based on whether it's encapsulated in IP or IPv6. Like, I don't know. I mean, I get it, right? They're trying to prevent the checksum from passing if the IP, if it's like put on a different IP packet, but it's such a mess. It's so nasty. It should really be strictly, in my opinion, as you know, obviously, who am I to criticize the great network creators of the 1970s? But if you asked me, I would have said the checksum of every layer should only care about the things inside of it. And indeed, every layer's header, the length field, everything should only care about its dependent data, so that it would be easier to like assemble these things without having to do this cross-layer stuff. But I am not, in fact, the president of TCP. Zero. What did I name this field in UDP land? I named the field len. I should name it len here. I also made this an IP protocol, which is sort of convenient. IP protocol, source and destination IP 0 and IP protocol. Should we just, I mean, what do we need? We need reply header. No, we actually super don't need reply header because that's not how TCP works. We're not going to be doing replies to packets. bswap would be very convenient to have, and then yeah, we need to like go straight into the checksum, I think. Source port, destination port, but there's also so much more. Nope. We're not going to touch the flags field because those do not particularly meaningfully bswap. The header length, but it's only 4 bytes. Like we won't need to touch this at all. We're going to just write some accessor methods for those and not worry about it. There's no length. It's all TCP length. Interesting. Oh gosh, so yeah, so that makes this length actually important. Because there is no length in the TCP header. And I don't mind the idea of having a pseudo header or other fields in the checksum. The thing I mind is that it's the IP address. It's really not what you should be concerned about. And it means that, like, if I wanted to define, TCP inside, like, I don't know, maybe I want to put TCP inside an IPX packet. Like, well, now I have to define a new checksum schema. It's like weird. I don't like it. And we definitely do want to change the urgent pointer. Dot swap. Did I leave? I super did, didn't I? Just leave like crazy amounts of, yes, I did. All right, we should get rid of all of this. Just, I wanted to basically copy this because the TCP checksum is going to be almost exactly the same. Yeah, we still need source and destination IP. That's still all we need. Protocol is TCP. Len is not, in fact, self.len. Ooh, we might need a we might need an additional field for this. Because we cannot get len from here alone, we're going to need the TCP, like we're going to need to get the IP total length and subtract the, God, that's going to be annoying. I'm not going to try to do any subtraction here because the IP total length is going to have to, like, I can't just say IP total length minus 20, the length of the IP header, because the IP header might have options. So really I have to say IP total length minus IP header length, and that's kind of messy, but it's I mean, it's fine. We'll just have to pass it in as an argument, which is annoying. Obviously, this is not a UDP header. This is a TCP header. Len. Pseudo header as TCP IP pseudo header. TCP IP pseudo header. Checksum. Okay. I don't even have a TCP frame to test this on, but it's just, you know, we just spent all that time doing the other one. I want to get this done too. That len is going to be annoying, but I just need to document what that is. Len is the length. Just so I don't forget what that is, because I can't do anything with it right now. We also need to name these things correctly. This is set IP checksum, and this is IP checksum, because we will have an IPv6 checksum potentially and whatever else. So TCP. TCP is now much more interesting because we can't just send the packets back. Turns out you can't just reflect the packets right back and expect it to work. Actually, in that specific case, it might if you literally sent the same packets in the same order, because you'd have the same sequence numbers and stuff. Well, no, you wouldn't, because there's the whole diagram, state diagram and stuff. So this is the diagram that explains how TCP works. I would not expect anyone to be able to look at this and just immediately understand it, but basically TCP is primarily interested. The main point of TCP is flow control. That's the main point, right? People will like to say, if you ask people on the street, why does TCP exist? They'll say reliable data transmission, but that is an aspect of what TCP does, yes. But the main point, the main thing that TCP does, the reason that it was invented and the thing that it provides is flow control. It is responsive to network conditions becoming adverse. Basically, as packets get dropped, the TCP flow slows down. It knows how to do that. That's the whole idea of the protocol. And the way that it accomplishes that is this state diagram, that you establish a session essentially with a single remote peer, right? This part of it should be very intuitive to you if you've ever done any like network, if you've ever requested a website or something like that, right? The way that it works is you say, give me a socket, associate it with this specific server, right? Google.com port 80. And that becomes a tunnel that you can ferry data back and forth. And yes, the algorithm is doing flow control. It's also doing reliable transmission, right? It's ensuring that the bytes go in the tunnel in the same order that they come out. But this is how that works, right? This is the control packets that get sent back and forth to define setting up that tunnel and also tearing it down. So we will need to make accessors in here for those flags. Like we'll need to be able to tell if it's a SYN packet, for example, or an ACK packet. But the first thing that we can do here is just make some, so it's a state machine, right? So we need to have some states. And what are those states? Well, close. I'm just going down the diagram, not in any particular order. And that's all of them, I think. How many did we make? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 states. Cool. And then single packets, individual packets, move the connection between these states. So, for example, if an application opens a listening socket, say you're hosting a web server, and you receive listen, right? Shouldn't you? Isn't there a receive? Yeah, receive SYN. There it is. It's hidden way over here. You receive a SYN, then you end up in this state. And then if you then receive a, what are the outs? If you can receive an ACK, and you get into established state, you can't, okay, it doesn't say what happens if you like receive a fin in the middle of a SYN, but I don't know. SYN, the normal path, SYN, ACK, send data back and forth, fin, done. Yeah, I mean yeah, I guess it's not indicating every possible state transition. It's the dotted path is the normal server transition, and the solid path is the normal user client path, right? So your computer would normally send a SYN, receive SYN ACK, send ACK, send data, close, done, back to the beginning. So what is this state machine going to look like? Well, I'm going to cheat just the tiniest little bit here and look at the last time I did this in C because I don't want to remember what all the fields are. So I'm going to cheat. This was socket, I think. Yeah, net. This is what it was. This is an interesting question, actually. I've been calling these, like, this is TCP header, but it's also in mod TCP. So should it be TCP header, or should it be TCP : header? Because right now it's, which is kind of repetitive. I don't know. We'll have to think about that. This is definitely pub. So they are, we definitely care about like, we care about like address as IP and port. And sometimes there's an other address, but not always. You can definitely have an open session, right? If we go back to the state diagram, in listen state, there is no other client. So that's probably just an optional address. I don't know. We will definitely need things like receive buffers. We're not going to worry about those yet. The sequence numbers, I think that's a really interesting question, actually. What are we going to store them in? Because Rust is always very unkind when you want to change the types of numbers. So if we need to use this to index into anything, we should really make it a usize, but I don't think we will. I think it should be a U32 because the sequence number is a U32. So we're going to need to do math on these with this. I think it should really be that. So send ACK is the last sent byte for which we have received an ACK. That's not a very, I don't think this is a I don't think I like these names, but we're gonna maybe I should just go with the protocol names. Just go with the protocol names. And change those names later. And then we're definitely going to need some sort of queue of accepting packets, but or not accept, some sort of queue of unact packets. No, it's the out of order queue that we'll need to deal with, but that's a later problem. The buffer is a later problem. Cool. So just basically wanted to remember what these three things were. So really, IP should be a type so that I don't get the endianness wrong. But we'll deal with that later. Later problems. I don't know. Seems like a reasonable number to pick. Just pick random numbers and hope everything goes well. It's the only way to be, right? So That seems like something that we'll need, right? Like, right? Like receive a packet and edit internal state and buffers and stuff. That seems like something that we might need. We will definitely need, and I guess let's go ahead and do now the flag bits. So So we're going to have to think about this for a second because, again, with the big endian, right, which bit does this end up being? And I think I'm going to need a cheeky Wireshark to confirm. So let's just, I know there's going to be like a jillion packets on this. Yeah, 4,000 in that tiny little bit of a second. But here's our flags, and this should help us understand their order. So they are the low byte contains all of the interesting flags, and the fin bit is the least significant bit of the low byte. So this is, and that's the low byte in big endian. This is actually the most significant byte if I read it in little endian. And I am not byte swapping them, but maybe I should byte swap this. I don't know. You know, let's just do that. Let's just do that. Just so that I can be very confident when I say isFin is that, and isSyn 2 is reset 4 push 8 ack 16 urge 32. Should those be symbolic? Maybe. Should I make a constant? Almost certainly. But for now, it's fine. Do we care about anything else that's not here? That would be ECN echo, congestion window reduced, nonce, and then there's those 3 bits. We will care about that header length, and we should probably... That is not a bool. QRSTU TCP Huh? Missing. Header len is a U size, but you found unit because I put a semicolon there. Checksum supplied, okay, 58 because I meant no IP destination IP len. I do actually want to use random identifiers now that I know what is wrong with that. We need to import standard mem size of and network checksum 2-part. Seven. Oh. Who needs fun names when you can do weird stuff? Yes, I did not provide a definition for receipt packet. It was what we call an idea. And what was it? Create packet packet. Yes. Oh, because I need to make the checksum unsafe and provide the same caveat that I did at the top of UDP because it's the same function. Except that len is neither set nor correct because it doesn't exist. Call to unsafe function, yes. Because that's another unsafe function. You cannot have a window size of that. I don't know. Right, because the window size is like multiplied. Where's the window size? Window size. Is it really in bytes? It's definitely larger than bytes. Okay, I guess it's limited to that. That's surprising. All right, default is 16K. We can use that. 16384. But also, does it really not get bigger than that? I could swear that there was like a window expansion or something. Yeah, there is. The field can't be expanded. A scaling factor is used. The scaling option is used during the three-way handshake. The scale factor represents the number of bits to left shift the window size field. When does that? Oh, it's an option. It's a TCP option. So we might actually have to support options. Dynamic length headers. Who thought that was a good idea? So this super can't be 16 bits. This has got to be like U size. Just the Just the one in the packet is U16, but this is not U16. Okay. And so now we build. Yes, we do. We can pretty easily imagine what this would look like. Theoretically, there's a result of some description there, but we don't have that set up, right? This is basically going to be and then pull a bunch of this data. So source port, right, is right, and this is where the this is why you do a session, right? This is all data that we could not like pass into a send a TCP packet routine, right? There's just like so many parameters here. But a session, wow, you've just got everything you need ready to go. It's header len flags, which should be what is the standard header length? 20, and it's got a scaling factor of 4, so 5 over 12, because the normal packet is not going to include any flags. Maybe that's not accurate. Maybe you send ACK sometimes, but we could send explicit ACKs for now. Checksum 0. I don't know what that is. We're going to leave it there for now. And then that's it. That's the whole header. Right, and then we have a IP header. Let's just go ahead and copy the fields so that we remember what they are. Honestly, we probably could make this should probably be a like, excuse me, IP header default TCP or something like that just makes the default one, but because I really should not have to say, oh, version IHL, well, that's OX45, and DSCP ECN is 0. Total len, I mean, we can solve this now. It's 20 plus 20 plus data.len. ID. Does this need to be? This might need to be something specific. We're going to make it 0 for now. Did I do that? Please tell me I did that. I did, and it's public. I'm so good. So good at this. Self address 0. My spacebar is doing something weird. It's like come out of the stabilizers or something, so it's like leaning up when I press on it on the one side. I'll have to fix that. Okay, so then the other sort of interesting question is, because sure, like we could we can go straight to that, but the other interesting part is, I think it's sequence. This has also got to be mutable reference to self, by the way. Sequence number has got to go up by data.len, and that should be dot wrapping add. Right? This is one of those where, right, Rust super does not want you to do evil things with integers. So like in C, obviously everything is sort of wrapping arithmetic by default. But in Rust, you have to be very explicit. And I never remember which one is which. So there's overflowing add, which is going to give me a overflow bit. I don't care about the overflow bit. Saturating add is going to saturate to max. I very much do not want that. Wrapping add is just going to return a U32, and yeah, modular addition. That's what I want. And this is also return a new, so it's self.sequence number dot wrapping add data.len. And that should be what I expect. It's an interesting idea. I solved this with a generic. I wonder if we can... Actually, we super can. I can get rid of a bunch of this crap with network checksum if we just make this T as slice. Well, it's not the same. It's not as slice. I can definitely do it with a generic. It's definitely doable. I'm not going to try to do it right now. But basically the idea being, instead of passing this as a starconst U16, I can probably just make this generic on the type and convert it to a pointer internally. I mean, it'll have to be a reference so that you can still get, right, it's got to be the same memory address, literally. And that might be annoying, actually. Well, I say that, but you could do, right, correct me if I'm wrong, Rust, but I'm imagining that I can say this is generic on T. T is debug. Just so that I have something that I can do something useful with, like print it out. Value then is reference to T. And maybe this is going to tell me that just because T impls debug that ref T doesn't necessarily, but let's see what happens. I don't think I've ever tried this. I'm presuming the numbers impl debug. Honestly, that could even be display. Who cares? Yep, that works. So that's valid. We could make a... We could do that. We need a new... Right, it would be... Maybe like... as putter or something. I don't know. Which literally just... Heck, you don't even need self-sized at that point, I don't think. That's actually... Nor do you care about lifetimes. Nor do you, honestly. With the exception that that can't be... Yeah, I don't know how to make sure that... I mean, I guess that's the answer, is you just make this reference. I don't know. We're not doing this right now. We're super not going to do this right now. Fill checksums. So that's sort of, I mean, this is like an outline, right? This is not complete, but what is received then going to look like in the trivial case, because obviously there's the case of other address is none, and we have no, like we have to do an accept operation or something, but we're going to ignore that for the moment. This becomes a question of, hey, if, well, okay. If it's a sin, right? Now we just have to like go into the, well, we never actually put the state in here. We wrote the state and we never put it in here. That receiving a packet is where a lot of this state machine stuff comes in. So if we're in, I don't know, closed, right, we're gonna do something with this, like maybe reject it, right? That's the ICMP, etc., etc. And we probably wouldn't actually send a port unreachable. That's probably not a good idea. It's never a good idea to tell your attackers what your servers are doing. But just for the sake of being relatively close to what the standard's intent was, we could say that. But so I think this is definitely where we're going. I think this is a good direction. I think this is what I was excited about doing in Rust in the first place. This is why I wanted to work on this. That along with the if established, right? We're gonna put this onto a priority queue. It's gonna be good, right? We're gonna be able to reassemble, or it's gonna be really slick. All the things that doing it in C made really difficult. But I don't think I'm going to do that today, because I have been going for 3.5 hours, and I had dinner. I don't know why I'm hungry, but I am super hungry. So I hope everybody who was watching enjoyed. I hope this was informative, or at least entertaining. And I hope you have a great rest of your days. I've appreciated everybody who came by being here. I appreciate the questions earlier. And yeah, have a great rest of your days. And I will see you maybe tomorrow. Depending on how I feel after work, we might get right back into this. If I have a harder day, maybe not tomorrow, but I will definitely see you around. Bye.